Binary search is almost like a party trick of an algorithm. It's just something simple that we don't think about, and it really blows your mind. Two friends, Jack and Rick, are going to play a game where Jack chooses a number in his head, he doesn't tell Rick, and Rick tries to guess. And Rick can use any strategy he likes, but the only information he's given is if the secret number is above his guess or under it. Is it 1? Nope. Higher. Is it 2? No. Higher. Is it 3? Higher. 4? Higher. Come on, man. Like, as you can tell, Rick's strategy is pretty bad. He's just guessing in a linear format where he's going 1 to 100 and hoping that he's gonna get it early on. But in this case, Jack's secret number is 74, and that means it's gonna take 73 guesses to get to the final answer. And that's a lot of guesses to get to the answer. And it can get a lot worse. It can also get better, but when you're guessing out of 10,000, the chances are that you're gonna be taking a lot of steps to get to the result. And that's why that strategy that Rick is using is really bad. It's not optimized, and he could do it better. With binary search, it would take him 7 steps to get a number that he's right now would take 73 steps to get to. Yep, only 7 steps versus the 73 with the other strategy. Binary search is almost like a party trick of an algorithm. It's just something simple that we don't think about, and it really blows your mind. This is what it would look like if Rick used a binary search to get the answer. Okay, I think I got this. Is it 50? No. Higher. Is it 75? No. Lower. 62? No. Higher. 68? Higher. 71? No. Higher. 73? No. Higher. 74? Yeah, dude, that's it. Hell yeah! Nice job. So if you didn't catch the pattern, with binary search, what happens is you keep choosing the middle number, and then from there, you know if the number is higher, then you're going to take the upper portion, and if it's lower, you're going to take the bottom portion. So in this case, we're choosing between 1 and 100. So we're going to go 50, and if it's higher, that means the answer is in between 50 and 100. If it's lower, it means it's between 1 and 50. Right there, you cut out half the numbers, and now there's only 50 to choose from. And you repeat the process. And once you figure out that it's on the lower half, so Rick asks if it's 75 and Jack says no, lower. That means the answer is between 50 and 75. All the other numbers, the 75 other numbers that we've had, are useless because we know it's not in those ranges anymore. And then we repeat the process and repeat the process until in 7 turns, Rick gets the answer of the secret number, which is 74. Binary search is really something amazing. It works in log n, meaning the bigger the problem gets, it's still very fast. One thing I should mention is that binary search does have to be ran on a sorted array. So if you're getting an array and it's not sorted, you'll have to use a sorting algorithm and then binary search. And that's where problems come in. Because yeah, binary search is very fast on its own, but when are you always, you're not always getting a sorted array, and that's where the time complexity issue comes in, and there might be a different algorithm that's better for you. I have an example written in Python, so let's go over it. There are a couple of things here that you can ignore, like line 1 and 4, 5, and 6, where you have that count variable. That's just for demonstration purposes, but don't worry about that. So let's go line by line and see what's happening. On line 1, I have count equal to 0. Like I said, that's for demonstration purposes. That's just for me to show you guys how many times this thing has ran. So let's skip to line 8 where the real code happens. So on line 8, 9, and 10, the first thing we're doing is finding the middle of the input array. We get the length of it, we split it in half, and we make sure the number is a whole number, not a decimal, because you can't put in a decimal number to look up an item in an array. Then once we find the middle item, we go straight into line 14, where we check if that middle item is the value we're looking for, because it could be that you'll just get the first guess. In our case, let's say Jack picked 50, and Rick was like, okay, 50 is in the middle, is it 50? And Jack would have been like, yep, and that's in one try. Versus him counting 50 times to get to the number. Then if it's not the middle number, we check if it's on the lower half or upper half, and depending on which one, we're gonna rerun this whole function on that half using recursion. So you can see on line 18 and 20 where we call the function that we're inside of, but we call it on either the left half of the array or the right half. It's pretty simple. Recursion might be the most complex thing you guys look at here for those who are new to the process, but I made a video on it. I'm gonna link it below so you guys can go check it out. Then on line 22, we have an example array. That's our input array. That's not the most important thing for you guys to know, but that's what the game was in the intro scene. Now let's run the function. And this is what we get. We get 7 steps of the guesses, so 50, 75, 62, 68, 71, 73, and 74. Then we can see it stopped there, so 74 is our answer. And then the 7 at the end is the amount of steps it took to get there. So let's try running it with another number. I put in the number 99 and this is what we got. 50, 75, 88, 94, 97, and 99. It took us 6 steps to get the number 99. With the other strategy, it would have taken us 98 turns. 98 turns to get to this point. Now let's try something a bit different. I hope up to now that everything is starting to make more sense for you, but if it's not, I'm going to show you one last thing on this program where I can show you an animation of how this works. We're going to break it down, and I'm going to make sure that you're going to leave this video knowing what binary search is and how to write the code for it. Here we have a program that's going to show us the step-by-step process in a visual format of what we're doing. I'm going to put in the number 12 and we're going to run it step by step and see what happens. So it took us 3 tries to get the number 12. Let's analyze what happened. Step 1 is guessing in the middle. Our array length is 20, so the middle is going to be 10. Step 2 is guessing on whichever half the number was. In this case, the number was higher than 10, so we guessed on the top half, which is 10 to 20. And in the middle of that is 15. It's not 15, so we're going to keep going. It is lower than 15, so we're going to jump into the lower half. And we could see that we found it. Now the middle of 10 and 15 is 12.5. But since you can't put in a decimal number into an array, we have to round it down or round it up. Now that's to your preference, but in this program they round down, which is why in 3 steps we find the number 12. If you have any questions, feel free to join the Discord. There's a link for it in every single video that I post. If the link doesn't work, comment and I'll send you a new one. There's a bunch of people in the Discord, videographers, cinematographers, photographers, programmers, a lot of programmers, probably mainly programmers, and we all help each other. There's some experience, there's some unexperienced, and it's a really nice community, and we're all there to help each other. If you enjoyed my content, it would really help me if you can like this video and maybe check out the playlist of the algorithms and data structures. I got a couple other videos in there and a lot more coming in this week. If you're trying to learn how to edit videos like mine, learning to color grade, maybe even shoot a short film, I got a bunch of content on that stuff and a bunch more coming. Thank you for taking the time of your day and spending it here, listening to me talk about something that I'm really passionate and really happy to teach you guys. I gotta go. See you in the next one.